Pollution is often described as one of the defining environmental challenges of modern civilization. It affects the air we breathe, the water we drink, the soil that grows our food, and the ecosystems that support life across the planet. But while pollution itself is easy to see, smog in the air, plastic in the ocean, contaminated rivers, the systems designed to fight pollution are often invisible. Behind the scenes, cities and industries operate enormous networks of infrastructure that clean water, filter air, process waste, and monitor environmental health. These systems work continuously, day and night, quietly preventing pollution from spreading and protecting the environments we depend on. Most people rarely notice these systems because when they work well, they stay out of sight. To understand how we combat pollution, we need to look at the infrastructure built specifically to control it. One of the most important systems deals with water pollution. Every day, homes, businesses, hospitals, and factories generate wastewater. This water contains everything from organic waste and chemicals to cleaning products and microscopic contaminants. Without treatment, this wastewater would flow directly into rivers, lakes, and oceans. That's why modern cities rely on wastewater treatment plants. Wastewater treatment plants are designed to remove harmful substances from sewage before releasing water back into the environment. These facilities are some of the largest and most complex environmental infrastructure systems in any city. The process usually begins with screening. When wastewater arrives at a treatment facility, it passes through large metal screens that capture debris such as plastic packaging, wipes, paper products, and other materials that shouldn't be flushed into sewer systems. Removing these materials protects the rest of the equipment used in treatment. After screening, the wastewater enters grit chambers where sand, small rocks, and other heavy particles settle to the bottom. These materials can damage pumps and machinery, so removing them early is critical. Next comes primary treatment. In large settling tanks known as clarifiers, wastewater is allowed to slow down. As the water sits in these tanks, heavier organic solids sink to the bottom, forming a thick sludge layer. Lighter materials float to the surface and are skimmed away. At this stage, a significant portion of the solid waste has already been removed. But the water still contains dissolved pollutants and microscopic organisms. This is where secondary treatment begins. Secondary treatment uses biology to remove organic waste from the water. In large aeration tanks, wastewater is mixed with oxygen and beneficial microorganisms. These bacteria feed on organic pollutants, breaking them down into simpler substances. The microorganisms convert waste into carbon dioxide, water, and other byproducts that are much less harmful. After this process, the water flows into another settling tank where the microorganisms settle out, leaving much cleaner water behind. Many treatment plants also include a third stage called tertiary treatment. Tertiary treatment further improves water quality by filtering out remaining particles and disinfecting the water. Chlorine or ultraviolet light may be used to kill harmful bacteria and viruses. By the end of this process, the treated water is often clean enough to safely return to rivers, lakes, or oceans. But wastewater treatment is only one part of the effort to combat pollution. Air pollution presents another major challenge, particularly in industrial regions and large urban areas. Factories, power plants, and vehicles all release gases and particles into the atmosphere. Without controls, these emissions can contribute to smog, respiratory illnesses, and environmental damage. To reduce these pollutants, many industrial facilities use specialized equipment designed to clean emissions before they are released into the air. One of the most common technologies used is the smokestack scrubber. Scrubbers remove harmful gases from industrial exhaust by spraying liquid solutions that capture pollutants as the exhaust passes through the system. This process can remove sulfur dioxide, which is a major contributor to acid rain. Another important technology is the electrostatic precipitator. Electrostatic precipitators use electrical charges to capture tiny particles in industrial emissions. As polluted air flows through the system, particles become electrically charged and stick to metal plates inside the device. These plates are periodically cleaned, removing large amounts of particulate pollution from the air. Power plants, steel mills, and cement factories often rely on these technologies to meet environmental regulations and reduce harmful emissions. In addition to industrial controls, many cities operate air monitoring networks. Across urban areas, sensors measure pollutants such as nitrogen dioxide, ozone, and particulate matter. These monitoring stations provide real-time data about air quality and help governments respond when pollution levels become dangerous. The data collected by these sensors also helps researchers understand pollution patterns and develop strategies to reduce emissions over time. Solid waste is another major contributor to pollution. Modern cities produce enormous amounts of garbage every day. Without effective waste management systems, this waste could quickly contaminate land and water. To address this problem, cities operate complex waste management infrastructure. Garbage collection systems transport waste to sorting facilities where materials are separated for recycling, composting, or disposal. At recycling plants, machines use magnets, optical scanners, and air jets to identify and separate materials such as metals, plastics, glass, and paper. These materials can then be processed and reused in manufacturing. Recycling helps reduce pollution by lowering the demand for raw materials and preventing waste from entering the environment. Landfills also play a role in modern waste management. Although landfills are often associated with pollution, modern landfills are carefully engineered to reduce environmental impact. They use protective liners to prevent chemicals from leaking into groundwater and systems that collect methane gas produced by decomposing waste. In many cases, methane collected from landfills is used as a source of energy. Another growing strategy in pollution control involves renewable energy. Burning fossil fuels releases large amounts of carbon dioxide and other pollutants into the atmosphere. Renewable energy sources such as solar, wind, and hydroelectric power generate electricity without producing these emissions. By replacing fossil fuel energy sources, renewable infrastructure helps reduce air pollution and greenhouse gas emissions. But combating pollution isn't just about cleaning up after waste is created. Increasingly, the goal is to prevent pollution from occurring in the first place. Industries now design manufacturing processes that reduce waste and emissions. Cities promote public transportation and electric vehicles to reduce air pollution. Governments establish regulations that limit harmful chemicals in industrial processes. Technology also plays an important role. Satellites now track pollution across the globe, monitoring air quality, ocean contamination, and environmental changes in real time. Sensors placed in rivers and lakes detect pollution levels and alert authorities when contamination occurs. These technologies allow governments and scientists to respond quickly to environmental threats. Ocean pollution has also received increased attention in recent years. Plastic waste has accumulated in large areas of the ocean, creating floating debris fields known as garbage patches. In response, engineers and environmental organizations have begun developing systems designed to capture plastic waste from the ocean's surface. At the same time, many countries are working to reduce plastic production and improve recycling systems to prevent plastic from entering waterways in the first place. All of these efforts, wastewater treatment, air filtration, recycling systems, renewable energy, and pollution monitoring, form a massive network of environmental infrastructure. Together, they represent one of the largest coordinated efforts to manage the environmental impact of modern civilization. The systems that combat pollution are rarely visible to the public, but they operate continuously in the background, protecting ecosystems and human health. Without them, cities would quickly become unsafe places to live. The next time you see clean water flowing from a faucet or breathe relatively clean air in a large city, it's worth remembering the infrastructure working quietly behind the scenes. From wastewater treatment plants and industrial scrubbers to recycling centers and environmental monitoring networks, these systems form a critical part of the hidden infrastructure of the world. And as populations grow and industries expand, These systems will become even more important in the decades ahead. Understanding them is one step toward appreciating the enormous effort required to keep our environment healthy. Because the fight against pollution doesn't happen in one place. It happens everywhere, in pipes, treatment plants, power stations, laboratories, and monitoring stations across the planet. And most of the time, it happens quietly, out of sight, but always working. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.